Hey there, how's it going everybody? In this video we'll be learning about lists, tuples, and sets in Python. Now lists and tuples allow us to work with sequential data, and sets are unordered collections of values with no duplicates. And we'll look at all of these to see exactly what that means. So first let's look at lists, and we're going to spend a majority of the time on lists just because it has a lot more functionality than the other data types. So just like the name implies, it allows us to work with a list of values. So for example, let's say that I wanted a list of courses. So I could create a variable here called courses. And to create a list, we're going to use these square brackets. And within these brackets, we put each value that we want separated by a comma. So for example, let's say that we wanted a list of courses. So I'll say history and math and physics. And also, lastly, we'll put in comp sci. So now if we print out this list, so I'll print out courses and run that, then we can see that it prints out our entire list. Now, if we wanted to see how many values are in our list, then we can get this by using the len function, which stands for length. So if instead we print out the length using len of courses and run that, then you can see that it says that we have 4 values in our list. And we can access each of these values individually. So first let's go back to just printing out our lists and running that. So now to access the values in our list, we can use square brackets after our list and pass in the location of the value that we want. So we can put in square brackets, and this location is called an index, and it starts at 0. So to access the first value of our list, we can access the location at index 0. If I print that, then we can see that we get history. Now, since the length of our list is 4, that means with the first value starting at index 0, then the last value will be at index 3. So it's our total length minus 1. So let's say I wanted to grab the last value from my list, which is comp sci. I could count these indexes out and see which one should be able to access it. So 0, 1, 2, and 3, the third index. So if I print out courses 3 and access that index of 3 and run that, then we can see that we printed out comp sci. Now we can actually use negative indexes too, and negative indexes will just start from the end of the list. So since 0 is the first item of our list, I can also get the last item of our list using a -1. So if we print out courses index of -1 and run that, then we can see that we got comp sci again, which is the last item. It's more convenient a lot of the time using a -1 to get the last item because we don't have to worry about what the length of the list is. So for example, if my list grew by 10 items, then the third index would no longer be the last item, but the -1 will always be the last item. And also, if you accidentally try to access an index that doesn't exist, then you'll get an index error. So in this example, if we tried to access an item at index 4 and run that, since there is no index 4, you can see that we get this list index out of range. Now, instead of only grabbing one value, we can also access a range of values. So if I wanted to grab the first 2 values from this list, then I could say that I want to access starting at index 0 and go to, but not including index 2. So this first index is our starting point, and the second index, which is separated by this colon, is the stopping point. Now, one thing that's a little confusing is that the first index is inclusive, but the second index is not. And there's good reasons for that, but it's easy to forget. So what we're saying here is that we want all of the values between the beginning and up to, but not including, the second index. So if we run this, then we can see that it printed out history and math because it printed out 0 and 1 all the way up to 2, but not including 2, which is physics. Now, since our first index here is just the start of the string, we can actually just leave that off, and it will assume that we want to start at the beginning. So if we said print the courses with nothing there, :2, and run this, then you can see that we get the same result because it just assumed that we wanted to start at the beginning. Now, if we just wanted to grab physics and comp sci from this list, then we can say that we want to start at index 2 and then put in our colon. And now, just like our starting index, if we don't put anything here, then it's going to assume that we want to go all the way to the end of the list. So if I run this, then you can see that it printed out physics and comp sci because it started at our second index, which is physics, and just went all the way to the end. Now what we're doing here is called slicing, and if you'd like to learn more about slicing in depth, then you can watch my detailed video on that, which shows you how you can skip values, go in reverse, and things like that. And I'll leave a link to that video in the description section below. Okay, so let's look at some list methods that we have available to us that allow us to modify our list. So first, let's say that we wanted to add an item to our list. There are a couple of ways we can do this. So first, if we just wanted to add an item to the end of our list, then we could use the append method. So let's say that we want to add art to our courses. So we can just say courses.append, and we want to append art. So now if I remove this slicing and just print out our courses list and run that, then you can see that art was appended here to the end of the list. Now if we wanted to instead add art to a specific location in our list, then we could instead use the insert method. Now insert takes two arguments. First, it takes the index where you want to insert the value, and then the value itself. So if I wanted to insert art to the beginning of our list, then we could say courses.insert, and now the first argument is the location. So let's just say location 0, which is the beginning, and then the value that we want to insert, which is art. So if we run this, now we can see that art was inserted at position 0. Now that only inserted the value, it didn't overwrite anything. So you can see that all the other courses are still here, but they just got shifted. Now another way of adding values to our list is using the extend method. Now sometimes this confuses people, so let's look at what this does. So we want to use extend when we have multiple values that we want to add to our list. So for example, let's say that we have another list here called courses 2, and we'll set this equal to another list with art and education in this list. And we want to add these values to our original courses list. So first, let's see what happens if we use this insert method. So instead of inserting art to the beginning of our list, let's instead insert these courses to the beginning of our list. So let's go ahead and run this. So we can see that at the beginning of our list that it actually added the entire list of courses 2 and not each individual value. So we can actually have a list within a list like we have here. So if we were to print the first value of our courses list, so I'll print out the index of 0 and run that, then we can see that now the first value is actually this list itself. But this isn't really what we wanted. We wanted to add all of those values from our second list to our original list. Now that is why we use the extend method. So let's go ahead and set this back to the way it was to just print the courses. Now instead of inserting here, we'll instead use extend, and it only takes one argument, which is the iterable. So we will extend courses with courses 2. So now if we run this, then we can see that when we did courses.extend with courses 2, that it added the values from our second list here to our original. So a lot of people get that mixed up with append and extend. So again, if you were to append it, just like with insert, then it's just going to append the list itself on there instead of each individual item. So if we use extend, then now we can see that each individual item is extended onto that list. Okay, so now let's look at how we can remove some items or remove some values from our list. Now, one way to remove values is to just use the remove method. So if we were to say courses.remove, then let's say that we wanted to remove math. So if we save that and run it, then we can see that math was removed from the courses list. Now there's also a way of removing values with this pop method. So if we say courses.pop, now by default, this will remove the last value of our list. Now this is useful if we want to use our list like a stack or a queue. So if we run this like it is, then we can see that comp sci was popped off of our list, and now we just have these 3 courses. Now, one other thing about pop is that it returns the value that it removed. So we can actually set a variable and grab that returned value. So if I set a variable here and say popped equals courses.pop, and then I was to print this above our courses here, and run that, then we can see that it grabbed that comp sci value that was popped off of the list. So if you had a stack or a queue, then you could go through and just keep popping off values until your list is empty. Okay, so now let's look at how we can sort our list in a couple of different ways here. So first of all, let's say that we just wanted to reverse our list as it currently is. Now this is pretty easy. So we can just use the reverse method. So I can say courses.reverse, and if we run this, then we can see that now it prints out our courses, but in reverse. So the last item all the way up until the first item. Now, instead of reversing our list, what if we wanted to sort our list? Now, sorting is just as easy. We can just use the sort method. So I'll save that and run it. And you can see that now our list is sorted in alphabetical order. So comp sci, history, math, physics. Now, if our list contained numbers, then it would sort those in ascending order. So let me create another list here of numbers. I'll just call that nums. And I'll set this equal to some random values. So I'll say 1, 5, 4, and 3, and we'll save that. Now below courses, we will just say nums.sort, and we will also print these out. So I'll grab that variable, print those out, and run that. So now we can see that our strings were sorted alphabetically and our numbers were sorted in ascending order. Now, what if we wanted our values sorted in descending order? Now, one way you might think to do this is just to use our reverse method on the list after they're sorted, and that would work, but there's an easier way to do this. Instead, we can just pass an argument to our sort method called reverse. So if I come up here to the sort method and I pass reverse is equal to true, and let me also grab this for our num sort, and if I run this, you can see that now these sorted are in descending order. They're sorted in reverse order. Now, one thing to notice here is that we don't need to reset our variables when we call most of these methods. It's just altering the list in place. But there's also a way that we can get a sorted version of our list without altering the original list. So what if we wanted a sorted version of our courses list without altering the original? So to do this, we can use the sorted function. So instead of calling this sort method on our list, we'll instead use this sorted function, and I'll pass courses in to sorted there. Now, if we run this as it is, then we can see that our list is not sorted. It's exactly how we described it up here. Now that's because the sorted function doesn't sort the list in place. It returns a sorted version of the list. So to get that sorted list, we have to make a new variable and set it to the return value of the sorted function. So I could just call this sorted courses is equal to the sorted version of that courses list. And now if we copy that and print that out, so now we can see that this sorted courses is equal to the sorted version of that list. So that's really useful because a lot of the times you won't want to alter your original list in any way. So using this sorted function is a nice way to get a sorted version of that list without altering the original. And other than this sorted function, there are a couple more useful built-ins that we can use with these sequences. So let's look at a few of these. So we'll look at min, max, and sum. So it's probably pretty obvious what these will do, but if I wanted the minimum value of our numbers list here, then let me comment out where we're printing out nums. So a built-in function that we can use is just min and call min on our sequence of numbers. And if I run that, then you can see that it returns 1 as the minimum number of that list. And if we wanted the max value of that list, then we could use max. And if I run that, you can see it returns 5. Now, if we wanted to print the sum of that entire sequence, then I can just say sum of numbers. If I print that, then it gets 15 because 1 plus 5 plus 2 plus 4 plus 3 is equal to 15. Okay, so lastly, let's see how we can find some values here within our list. So let me go ahead and clean up here a little bit and uncomment out that. So if we wanted to find the index of a certain value, then we can use the index method for this. So if I wanted to find the index of comp sci in our list, then we could just print out courses.index and then search for comp sci. Now if we run this, then we can see that we got 3. and 3 is the index where it found that comp sci value. Now, if we try to find the index of a value that doesn't exist in the list, then we'll get a value error. So if we search that original list of courses for art and run that, then we can see that we got a value error and it says art is not in the list. Now, if we just wanted to simply check if the value was in our list and simply get back a true or false result, then for this we can use the in operator. So if I wanted to check if art is in our list, then I could say art in courses. So if I run that, then we can see that we got false. But if instead we said math in courses and ran that, then that returned true. Now, this is going to be especially useful once we go over the topic of conditionals and if-else statements, and we're going to go over those in a couple of videos. And we can also use this to loop through values of our list by using a for loop. So if I was to say for item in courses, and then scoot that over, then we will just print out that item. Now, this is the first time in our series that we've indented a block of code. Basically, what we're saying here is that we want to create a loop where looping through each value of our list. And each loop through, this item variable will be equal to the next item in the list. So that's why this line is indented, because it tells us that this code is executed from within our for loop. So if we run this, then we can see that it prints out each item of our list. Now, the reason it prints them all out on a new line is because by default, the print statement goes to a new line each time it's executed. Now, this item variable is just a variable. It's not a keyword or anything. We can name this anything we want. So instead, if we wanted to, call this course for course in courses and print that out, then you can see that we get the same result. So we can access each value as we're looping through, but sometimes it might be useful to also have the index of what value we're on. Now, to do this in Python, we can access the index and the value by using the enumerate function. So I will say enumerate, and I will wrap courses within that enumerate function. And this enumerate function returns two values. It returns the index that we're on and the value. So instead of just getting the course here, we're also going to need to get the index. So I'll call that index. So for index course in enumerate courses. And now if we print out that index and the course and run that, then you can see that we had access to each index and value as we're looping through our list. And if we don't want to start at 0, then we can pass in a start value to our enumerate function. So if instead we wanted to start at 1, then I can pass in the second argument, say start is equal to 1. Now if I run this, then you can see that now our starting value is 1. Okay, so there is one more thing that I want to go over before we move on to tuples and sets. So it's pretty common that we'll want to turn our list into strings separated by a certain value. Now to do this, we're actually going to use a string method called join, and we're going to pass in our list as the argument. So for example, let's say that we wanted to turn our list of courses into a string of comma separated values. So we can say course string, and that'll hold the string version of our courses. And now we'll type the string that we want to separate each item of our list. So I want these to be comma separated. So I'll put in a string of a comma and a space. And then I'm going to use the join method to join the values of the list using this string. So I'll say dot join, and I want to join my courses on that string. So now if I come down here and print that string version of our courses and run that, then we can see that we get our values comma separated. And if we want to change this, then we can just change our string within that we're joining on. So if we wanted to hyphenate these, then I could just change this to space hyphen space and run that. And you can see that when we ran that, now we're separating these by the hyphen. So this is just one long string with all of our list values joined together. Now we can also do the reverse of this and turn a string back into a list. So we can do this by splitting our string on a certain value. So if I split the string that we just created, so let me create a new list here, and I'll set this equal to the string version of our list, and I'll do a dot split, and I'll split it on a space hyphen space. So if we look at the string version that we have down here, this is just one whole string. What that's saying is it's saying, hey, split up all of these values on this space comma space and make a list out of all those values that you get. So now if we print out our new list, so I'll print that new list and run that, and you can see that now we're back to the original list. Okay, so I know that that was a lot to take in because there's so much that we can do with lists, but now let's move on to tuples and sets. Now that we're familiar with lists, then these will probably go pretty quickly. Okay, so tuples are very similar to lists, but with one major difference. So we can't modify tuples. Now in programming, this is called mutable and immutable. So lists are mutable and tuples are not. They are immutable. So let's look at what this means. So I'm going to grab a quick snippet of code here from my snippets file just to compare these. So I'm just going to grab from here all the way down to here, and just go ahead and paste those in. So first we have a regular list here that we've already looked at, and we're going to look at one issue that you might run into with mutable objects. So what I'm doing here is I'm creating our list of courses, and I'm calling this list 1, and then we're creating another variable here called list 2, and we're setting that equal to list 1, and then we're printing out both of these. So if I run this, then we can see that both list 1 and list 2 have the same values. So now let me uncomment out this code where we're changing a value in the first index of list 1 and then reprinting our values again. So now if I run this, then we can see here that all we did was change the value at the first index of list 1. But by changing list 1's first value, it also changed list 2. And the reason for that is because they're both the same mutable object. Now, if you need to modify your list, then this mutability is what you want. But if you want a list of values that you know aren't going to change, then we can use a tuple. So let's look at a tuple example. So I'm going to comment out our mutable example here and then uncomment out our tuple example. So a tuple looks almost exactly like a list, but instead of the square brackets, we're instead using these parentheses. And after we create our tuple, we're doing the exact same thing. We're calling creating a variable tuple1 that is a tuple, and then we're setting this tuple2 equal to tuple1. And for now, I'll just comment out where we're changing that first value, and I'll run that, and you can see that both of these tuples are equal to the same list of values. But now, if we try to change that value at the first index of tuple 1, just like we did with our list, if we run that, then we can see here that we get an error, and it says type error, tuple does not support item assignment, and that's because it's immutable. So now, since a tuple is immutable, it doesn't have nearly as many methods as a list, because a lot of those list methods that we looked at involved mutating the values. So we can't append, we can't remove anything or anything like that. But other than that, they behave pretty much the same. We can loop through tuples, we can access values, and all the other things that we've already seen, except for what mutates the list. So that's basically the difference between list and tuples. If you need something that you can modify, then use a list. But if you just want something that you can loop through and access, then you might want to think about a tuple so that you don't run into the issues that we just saw. Okay, and lastly, let's look at sets. Now, sets are values that are unordered and also have no duplicates. So let me grab a sample from the snippets file here that we can see. So I'm just going to go ahead and grab this small snippet and paste that in. So we can see that this looks similar to lists and tuples, but instead of the brackets or parentheses, we're instead using these curly braces. Now, if I run this code to print this set out, then we can see that it prints out the values, but if you notice here, these aren't in the order that we added them. So we had history first here, and it has history last down here. And if I run this a couple more times, then we'll see that, this order can change with each execution. Now the reason for this is because unlike our lists or tuples, sets don't really care about order, because some of the main uses for a set is either to test whether a value is part of a set, and also it's used a lot to remove duplicate values, because sets throw away duplicates. So first let's look at how to get rid of duplicates. So if I add another math course here to the end of our set, And now if I rerun this, then we can see that we still only have 4 courses. It got rid of that second math course and it just left us with the 1. Now another thing I mentioned was that it's used to test whether a value is part of a set. Now this is called a membership test. So sets do this a lot more efficiently than lists and tuples. So what I mean by this is that within our print statement, if I was to say math in CS courses and I run that, then we can see that it prints out true. Now we could do that with lists and tuples also, but sets are optimized for this. Okay, and lastly, something else really useful that sets can quickly do is determine what values they either share or don't share with other sets. So for example, let me create another set called art courses, and I'll create this pretty similar to CS courses here. But instead of physics and comp sci, I'll instead say art and design. And with both of these, I'm going to go ahead and take out that extra math on the end, just so it's a little bit more clear. And instead of this being CS courses, I'm going to call this set art courses. So now we have 2 different sets here, and some of them have different courses and some of the courses are the same. So let's say that I wanted to see what courses these sets had in common. So to do this, we could use the intersection method. So we can say CS courses dot intersection, and we will pass in the art courses into that. So if we run that, then we can see that it shows us that the history and math courses are in both of those sets. And if I wanted to see what courses are in the CS courses but not the art courses, then I could use the difference method. So instead of intersection, I will instead say difference. So if I run that, then now we can see that it shows that the physics and comp sci courses weren't in the art courses. Now, if I wanted to combine both of these sets and print all of the courses offered, then I could use the union method. So I'll say CS courses dot union, and we want to union with the art courses. So if I run that, then we can see that now we get all of the courses printed out from both sets. So sets can definitely be useful for these kinds of use cases, and for these particular problems, they're much more performant than lists or tuples. Okay, so we are basically finished up with this video, but let me show you one last thing before we close this out, and that's going to be how to create empty lists, tuples, and sets. So I have these over here in my snippets, so let me grab these real quick and copy and paste these over here and bring this down a line. So I wanted to show this because there's a small gotcha when it comes to creating an empty set. So to create an empty list, we can either set it equal to empty square brackets, or we can use this built-in list class. And to create an empty tuple, we can use these empty parentheses or this built-in tuple class. Now to create an empty set, we actually can't use these empty curly braces. So this line right here is wrong. That's not an empty set. This is actually going to create an empty dictionary. So to create an empty set, the way to properly do this is to use the built-in set class with no values. And speaking of dictionaries, that's actually what we're going to cover in our next video. But I hope everyone feels comfortable now with working with lists and tuples and sets. But if anyone does have any questions about what we covered in this video, then feel free to ask in the comment section below and I'll do my best to answer those. Now, if you enjoy these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up. And also, it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, you can contribute through Patreon, and there's a link to that page in the description section below. Be sure to subscribe for future videos, and thank you all for watching.